Saxon Algebra 2, Lesson 81. Our topic today is multiplying and dividing complex numbers. As you can see, that P gave me a real run for my money today, so I don't know what we're getting ourselves into. But here we go. Complex numbers always take the shape of A plus BI. This part is the real number. It's just an ordinary number. There's nothing fancy about that. The B itself is a regular number, but the BI part we call the imaginary number. Remember, before this meant hashtag, it meant number. So play along with me on that. Remember that imaginary numbers come up when we get something like square root of -4. And we ask ourselves, okay, what would we multiply together times itself to get -4? Well, there's no such thing. The square root of 4, that's fine. So what we do is we separate the minus sign and put it in its own little box, right? Its own little pig house. Then this we can say is 2. And then we have a rule. We have a friend named Euler, a Swiss mathematician, who came up with this notation. He said that whenever you have that minus sign trapped in the little pig house, call it I. Okay, so we change this notation to 2i. So the square root of -4 is 2i. That's what creates imaginary numbers, is minus signs trapped in pig houses with even numbered roots, okay? So real number, imaginary number, together we call it a complex number. The other special rule about complex numbers we always want to remember is that when you have 2 i's and you can multiply them, that equals -1. And we've done a fair amount of simplifying with that, haven't we? These two rules, this second rule is going to come into play in our lesson today. Okay, so that's just a quickie review on complex numbers. And this is the kind of problem we're going to work. It says to simplify, and then we get this kind of business. Okay, we've seen something kind of like that before. We've seen fractions like this that instead of i's, they might have radicals in them. And they give us a similar kind of problem because there's no easy way to fix that. But again, it's the denominators. We don't like complex numbers in our denominators. That's just bad form. We're fine with them in the numerators, but as mathematicians, we just cringe, right? We just cringe when we see those complex numbers in denominators. And we don't like to have radicals in denominators either, do we? So it's a similar kind of headache. And the good news is the solution is exactly the same. We use conjugates. Whoops. Conjugates, and I'll remind you of what that is, to, I'm going to say destroy because I feel a little violent about it. Remember, a conjugate is the same binomial with the middle sign changed. The front sign, even if it's an invisible plus sign like this one, is exactly the same. So this conjugate would be 4 plus 2i. That's the conjugate. And then we have to do bottom. So whatever we do to the bottom, we have to do to the top, right? That's how we keep our fraction in balance, looking good. So that is the conjugate of our denominator, and that's what we will use to destroy the conjugate and bring happiness to the force. So what I'm going to do now is I'm going to multiply the bottom two expressions times each other. I'm going to do that first because I want to make sure that it really works. I'm going to make sure that conjugate really does destroy the way it's supposed to. Then I'll go ahead and I'll do the top multiplication so that we simplify both. Okay? So I always do the bottom first, the top second. I make the columns, and then at the bottom, I'll put my answer back together. So for the bottom, I could say denominator, but this seems more natural to remember. 4 minus 2i times 4 plus 2i. Now we're doing the dance. The dance, you remember, is old-fashioned. I imagine like kids in the 1930s wearing like scuffy white socks and brown shoes. The girls are wearing like nice cute little dresses, and the boys are wearing like old-fashioned blue jeans and striped t-shirts. And they're up in some, you know, Madame Lucille's dance studio. Hardwood floors, great big windows, sun streaming in. You can see the dust motes in the air. And there's chairs all lined up along the edge of the walls. The boys sit on one side, the girls sit on the other side. And the teacher will demonstrate a step, and then she makes certain girls dance with certain boys to practice it to make sure they know. This is the boys' row. This is the girls' row. We always start with this girl at this end of the chairs, and she is going to dance with these two boys. I guess this is a very small class. So she dances with 4, and when I say dance, I mean multiplies. 4 times 4 is 16. Thank you, sir. Now she dances with him. 4 times minus 2i would be minus 8i, right? Now she's done. She sits down, and it's this girl's turn to dance. She dances with this boy, and when we multiply, we go, oh, look, they both have a single I term. Huh, they line up. That's cool. And then she dances with this boy, and what do we get? We get minus 4i squared, right? Okay, everyone's danced. Now we're ready to add. Now look what happens. 16, hold on to that for a second. These cancel. This, according to our rule, can be simplified as plus 4. I'm going to write that over here because now it's just a regular number, isn't it? It doesn't have a complex I in it anymore. It just has, it's just 4 times minus 1. I'll write that here just so you remember what I'm doing. Right? I use this rule to substitute in the minus 1. So that becomes plus 4. There. Now you know where it came from. And I can say that our new denominator is 20. The conjugates have done their magic. Our denominator is now a nice, adorable, real number. It works just like it does when we use it with radicals. It cleans up all of the mess. It's like one of those magic erasers. Do you guys ever use those? They're melamine sponges, and they scrub dirt away like magic. I mean, hence the name, right? So we just, the conjugates are like magic erasers that fix that. Now we have to do the same thing at the top, and we don't expect any miracles here, but it's okay because we've cleaned up the denominator, and that's what counts. 4 times 2 is 8. 4 times 3i is 12i. Thank you, miss. You may sit down. Your turn. I think this is Sally over here. That's Penny and that's Sally. Let's use some classic old school names. All right, this is 4i plus 6i squared. Okay, so I'm going to do the same thing. I'm going to wait on that. I'm going to add this, 16i. Then I'm going to fix this. The I squared is minus 1, so this becomes a minus 6. And I get 2 plus 16i. Okay, it's looking good, right? It's looking real good. So now we can put these together, and I'm going to work over here. It's 2 plus 16i over 20. Now, it would be nice if that was our answer, but we can simplify, can't we? Or we can reduce, rather. Yeah, simplify, because I see even numbers all around. So what I'm going to do is I'm going to pull a 2. That's the biggest number I can get out of everything. I'm going to factor it out of the top. So it's going to be 2 quantity times 1 plus 8i. Remember, we need to hold that place. We can't just leave it as 8i, because then if we multiplied it back, we'd get the 16i, but we wouldn't get that part, right? So you have to put that in as a placeholder. Now it's over 20. Now I can reduce. That goes to a 1. This goes to a 10. Now we have 1 plus 8i over 10. But that is not the way we like to write complex numbers. They have to be completely separate. So, on to the next page. Let's see, we had 1 plus 8i over 10. Now we separate 1 over 10 plus 8 over 10. And now I'm going to make the I float, even though that is not my jam. I do not like a floaty, but we're just doing that for the answer, so I'm okay with it. This can reduce again, right? This can go to 4 over 5. So our final answer is 1 over 10 plus 4 over 5i. That was a lot of simplifying, wasn't it? But, I mean, what a cute answer. I'm a fan of that one. Okay, we just have one more. This one, example 81.2. It's not a lot harder. John just does a few things to try to make us crazy, because that's how he rolls. First of all, in the book, he writes it like this. He says, simplify. 4 minus 2i. Okay, that looks good. 2i minus 3. All right. What the heck? This is not okay. We don't like that. So what I'm going to do is write that, because conjugates or complex numbers are supposed to be in this form, right? So let's fix it. The top was fine. It's just the bottom. So it's minus 3 plus 2i, right? Because the minus goes with the 3 and the 2i is positive. Okay, so that's beautiful. Now we're ready for our conjugates. Remember, we leave the front sign the same. We just change the middle sign. Minus 3 minus 2i. And we're going to multiply top and bottom by that. I want to do the bottom first. John doesn't know my trick. Denominator, again. I know I'm being non-mathy, but you know what? Sometimes our brains need a break from all the math jargon. So I'm going to multiply these two first and make sure they work. Minus 3 plus 2i minus 3 minus 2i. Sometimes I like to leave a space in there so I have a little more breathing room. Sometimes I squeeze them. I want to make sure I can finish in this amount of space, so I'm squishing a little bit. All right, we're back in the dance studio. Are you ready? I can always see the dust motes sparkling in the sunshine as our children dance. How old are they? They're like 11 years old, right? They're kind of old. They're at that weird sort of semi-self-conscious stage where, you know, in early elementary school, a lot of boys and girls find it very easy and natural to be friends. But then somewhere around 4th or 5th grade, sometimes they get kind of hostile. I think that homeschooled kids avoid a lot of that emotional drama. I know my kids did, but public school kids often get weird at that time frame. But anyway, they're ready to dance. Minus 3 times minus 3, positive 9. Minus 3 times 2i. You guys, I would not be doing this if you were with me. Okay, she's done. Her turn. She dances with him. That's a plus 6i. And then here we go. This is the fancy one. We get minus 4i squared. That changes to minus 4 times minus 1. And that becomes plus 4, and I move it over there. As you get confident with these, you guys, you can start doing this in your head and skipping right to writing that down. When you feel ready, do it. That cancels. We took care of that. Our final answer there is 13. Our new denominator is going to be 13. I'm good with that. All right, now we have to do the top. 4 minus 2i times minus 3 minus 2i. Remember, we have no illusions that this is going to work out so cute. We're fine. We don't mind complex numbers in the numerator. It's just the denominator that we find unreasonable. Okay, minus 12 plus 6i, right? Minus 8i, and then we have plus 4i squared. That changes to a minus, so it's going to be a minus 4 over there. I crossed that out so I don't confuse myself. Minus 16 minus 2i. Okay, so as I get ready to put this together, I quickly glance across at my 3 different coefficients and we go, okay, those are both even. But this one's odd, so I couldn't cancel. Like if I pulled the 2 out of those, I couldn't cancel it against the 13. So there's nothing to cancel in this one. There's no further work we can do. So when I write it, I'm just going to be careful to get it right into this format so I don't have to write it multiple times. So it's going to be minus 16 over 13, right? This is the top, this is the bottom, minus 2I over 13. There's that beautiful presentation. I guess even better, I'd like it like this, with that minus sign in the middle and the I floating. That to me, that's ideal. I like this the best of all. Okay, if you gave me this on a test, I'd give you full marks, but this just makes the sunshine pour into my heart, okay? So that is how we deal with complex numbers in the denominator. We multiply by the conjugate to make it go away. And then we make sure we present our answer in this form. That is the end of lesson 81. How do you feel about it? I hope you feel good about it. We're going to be talking about complex numbers for at least another year. Jayla, Laura, and Vivian are up to their neck in complex numbers right now. They're graphing complex numbers in different ways. So they'll be your friends for quite a while. They don't get a whole lot more complicated, but we're going to keep them around and do different things with them. All right, that's the end of lesson 81. Goodbye.